Okay, so what we're going to do here is go through the chapter review evens. I'm just going to zip right along, and this way, if you don't know how to do some of this stuff, you can watch it and yeah, go from there. All right, number 2, got a right square prism. So that means the base is a square. It says the base edge is 3 and the height is 10. So height 10, I'll just use small b for base edge is 3. It says find the volume. So the volume is area of the base times the height. So the area of the base is 3 squared, the height is 10, the volume is 90 units cubed. Surface area is perimeter of the base times the height plus 2 times the area of the base. So perimeter of the base is going to be 12, 3 times 4. The height is 10. And we already found the area of the base to be 9. So you got 120 and 18 is 138 units square. All right, number 4. If a cylinder has a volume of 30 pi and a base with a radius of 3, what must its height be? So volume is 30 pi, base has the radius of 3. And the question is, what is the height? So it's a cylinder. So we know the formula is pi r squared h. So if 30 pi is equal to pi r squared h, the pi's will cancel. So 30 equals r squared, equals r squared h. R is 3, so 30 equals 9h. So h is 30 over 9, which is 3 1/3. Number 6, find the volume of a right cylinder whose lateral area is 60 pi. Again, we're looking at a cylinder and whose base has a diameter of 12. So you got a cylinder, diameter 12, lateral area 60 pi. So in a cylinder, the surface area is 2 pi 2rh plus 2 pi r squared. So this is the lateral area, and this is the area of the bases, right? 2 times the area of the base. So we know the diameter is 12, so the radius has to be 6. And we're asked to find the volume. So we need the height of, because the volume is pi r squared h. So let's put in what we know. So we know the lateral area, which is this, is 60 pi equals pi 2rh. So the pi's will cancel. We know the radius is 6, so 60 equals 12h, so h is 5. So we don't really need this part because we're just looking at, we got to find the volume. So we said to find the height, got the height is 5 now. So pi 6 squared times 5. So it's going to be pi times 36 times 5, 180 pi for your volume. And this is going to be in cubic centimeters. Number 8. Find the volume of a cylinder with a diameter of 8p and a height equal to the radius of its base. So height equals radius. And we're looking for volume. So volume again is pi r squared h. If the diameter is 8p, radius is 4p because it's half the diameter, and height would also be 4p. So you're going to get pi, got to be careful here, 4p goes, the whole thing goes in parentheses, squared times 4p. And so you're going to get pi 16p squared times 4p. And then you can use the commutative property to move the numbers together. So you're going to get pi times 16 times 4 times p cubed, because p squared times p is p cubed. 16 times 4 is 64. So you're going to get 64 p cubed pi. Good. Number 10. You got, it says, refer to the regular square pyramid at the right. Looks like it's upside down. Find the volume. So it looks like our base edge is 80. Let's go, base edge is 80. And then it looks like the height is 30. And for a pyramid, the volume is 1/3 area of the base times the height. So in our case, volume is 1/3 80 squared times 30. So that's what, 64,000, because 80 squared is 6,400. 30 times 1/3 is 10, so 6,400 times 10, 64,000. Number 12, find the volume of the cone at the right. So the volume of a cone is just like a pyramid, 1/3 area of the base times the height, so 1/3 pi r squared h. And we have the radius of 3 and a height of 6. So 1/3 pi 9, 3 squared is 9, times 6. So 1/3 of 9 is 3, 3 times 6 is 18. So 18 pi is the volume of your cone. Right, I know I'm going quick, but if you have any questions on any of this, obviously just email me. Or maybe I'm not going quick. Maybe you want me to go faster. I don't know. No one talks to me anymore. Number 14. If a pyramid has a volume 75 cubic centimeters, and its base has an area of 5 square centimeters, so capital B, what is its height? Notice how I'm writing this out, the structure. You know, I'm writing out what I know and what I have to find out, and that's keeps me organized. So the volume formula for a pyramid, 1/3 area of the base times the height. We know the area of the base is 5, so we can put that in. We know the volume is 75. So 75 is 1/3 times 5 times h. We're trying to figure out what the height is. So multiply both sides by, so 1/3 of 5 is 5/3. So you multiply both sides by the reciprocal, so 3/5. So 3/5 times 75 equals h. And so 5 goes into 75 15 times, and 15 times 3 is 45, so the height is 45. And we're in centimeters. Number 16. Find the volume of a pyramid X, ABCD, below, whose base is a rectangle with one side 11 and a diagonal of 61, and the altitude is 20. Okay, so it looks like the height is 20. By altitude, they mean height. We're looking for volume. It's a pyramid, so 1/3 area of the base times the height. And we got a rectangle for a base. So one side is 11, and the diagonal is 61. So we got to use the Pythagorean Theorem here. 11 squared plus, we'll call this the length. The length squared equals 61 squared. So 61 squared minus 121, that's 11 squared, is 3,600. So that means that our length is 60. Okay, so area of the base is going to be 60 times 11, so that's 660. So 1/3 times 660, and then the height is 20. So 1/3 of 660 is 220. So this should be 4,400. All right, 18. Approximate the cube root of 40 to the nearest 10th. So cube root of 40. So remember, I need to calculate and do that two ways. You can do the square root of 1/3. Sorry, take 40 to the 1/3 power, and you get 3.4. Says nearest 10th, so see 3.4. Or you can do 40 and that, or sorry, you can go to the math menu, and this is cube root here, and then type in 40. So whatever suits your fancy. Number 20. Calculate the cube root of, let's write down, cube root of 15 plus the cube root of 21 to the nearest 100th. So cube root of 15 plus cube root of 21. 5.225, and they're looking for the nearest 100th, so 5.23. 22. Give the surface area and volume of a sphere with a diameter of 3 millimeters. Okay, so volume of a sphere, 4/3 pi r cubed. Surface area of a sphere, 4 pi r squared. So if the diameter is 3 millimeters, radius is 1.5 millimeters. Sorry. So this one would be a pain to do in my head. So 4/3 times pi times 1.5 cubed. So volume 14.14 millimeters cubed. Surface area 28.27 millimeters squared. All right, 24. A sphere has a volume 40 pi. What is its surface area? So we got to work backwards to find the radius. So 4/3 pi r cubed equals 40 pi. So the pi's will cancel. Got to multiply both sides by 3/4. And so this right here will give you 1. 1 times r cubed is r cubed. Over here, 40 times 3/4 is, so 40 divided by 4 is 10. 10 times 3 is 30. So you're going to get the cube root of 30 is your radius. Now we want the surface area. So 4 pi, the cube root of 30 squared. So 4 times pi times parenthesis, oops, cube root of 30, end parenthesis, squared. 121.33 is your surface area. All right, 26. The edges of a cube are multiplied by 9. What happens to its volume? So volume formula for a cubed is s cubed. If you multiplied its edges by 9, then your edge would be 9s. And if you cube that, your new volume is going to be 9 cubed s cubed. So 729 s cubed. So it's going to be 729 times bigger. And you could try that with a simple number. You could say, hey, what if my side was 3? 5 cubed would be 125. Now if I multiply that by 5, my side would be 45. And 45 cubed is 91,125. And if you divide that by 125, you get 729. In other words, 729 bigger. All right, 28. The diameter of the sun is about 109 times the diameter of the Earth. How do their volumes compare? So the sun diameter, Earth. So let's just say the Earth diameter is d. Then the sun's diameter is 109 times d. And so the question is, how do their volumes compare? So they're both approximately spheres. So volume of the sun is 4/3 pi. Now we want radius. So 109 divided by 2 is 54.5. Yeah, so the radius is half the diameter. So if the diameter is 109 times d, the radius would be 54.5 times d. The volume of the Earth is half of d. Sorry, the radius is half d. So then 4/3 pi half d cubed. So let's just put the numbers in that we can put in. So ignoring pi a second, we're going to have 54.5 cubed. So we're going to get this really big number, 21,000 or 251,838 approximately pi times d cubed. And then the Earth is going to be 4/3 times 1/2 cubed, and you get 1/6 pi d cubed. So what is the difference here? So if I take my 215,000 number, divide it by my Earth number, Earth volume, I get hold on, 1.295 million times bigger volume. Oh, yeah. So, sorry, I'm just thinking in my head here. So here our radius are 109 times, the sun's radius is 109 times that of the Earth's. And if you cube that, you get this 1.295 million number. So I did this the long way to show you, but what you can do, similar to the previous problem, is because the diameter is 109 times bigger, the radius is also 109 times bigger. And if you take 109 cubed, that will give you the difference in their volumes, because the rest of the formula is the same. Okay, let's do 30. A right cylinder has a base radius r and height h. Find a formula for its lateral area. So we got our cylinder, radius is r, height is h. The lateral area. So the lateral area is the perimeter of the base times the height. The perimeter of the base is going to be pi times 2r, right? The circumference of a circle. And then the height. So pi 2rh is my lateral area formula. For part B, so this is part A. For part B, find the formula for its volume. Volume is pi r squared h. Boom. Okay, 32. A cube has edges 2x, find surface area and volume. So S is equal to 2x. So surface area, just have to remember to put that edge, the whole thing, in parentheses here. And then this square applies to both pieces. So 6 times 4 times x squared, or 24x squared. Volume, same deal. We're putting 2x, the whole thing, inside the cubed, and we get 8x cubed. 34. Two cylindric solids have congruent bases and equal heights. One of the solids is oblique and one is right. True or false? A. They have the same volume. That's true based on Cavalari's principle. B. The solids have the same surface area. Their bases are congruent. They have equal heights. One is oblique, one is right. Yeah, their surface areas are not going to necessarily be the same, but their volumes have to. Okay, 36. The two figures have the same height. Do they have the same volume? So looking at 36, you gotta look at the area of the bases. So the one is a triangle, a right triangle. So 1/2 of 8 times 6 is 24. That's the area of the base. And then the height, they have the same height, it says. The other one is 4 times 12 is 48. So the bases don't have the same area. So the answer is no. 38. How much paper is needed to make a cylindrical paper cup with a base diameter of 10, height 12? All right, so we're talking surface area here. So, but it's a cup. So it doesn't have a lid, right? Otherwise you won't be able to put anything into it. So base diameter is 10, height's 12. So we're going to take pi times 10, that's the circumference of the base, and then times 12, this is the lateral area. But we also need a bottom, so pi 5 squared, the radius is going to be 5. So this should get us what we're looking for. So we got 120 times pi plus 25 times pi gives us 455.53, and this is in square centimeters. Just make sure you don't put a top on your cup, like some of you put a top on your ice cream cone on the quiz. A paper holder for an ice cream cone is in the shape of a right cone. If its slant height is 6 and its radius is 2, what is the lateral area? So the lateral area of a cone is 1/2 slant height times the perimeter of the base. So 1/2 times 6, and then the perimeter of the base is pi times 2r, which is in case is also 2. So we've got 12 pi, which is about 37.7. We're stuck. Okay. 42. To the nearest square foot, how much leather is needed to make a basketball that's 9.4 inches in diameter? So we're looking at surface area here of a sphere. So that's 4 pi r squared. So r is going to be 4.7. So 4 pi 4.7 squared. And so you get 277.59 inches. Oh, I read the directions again. It says to the nearest square foot. So there's 12 inches in 1 foot. And if you square, you get there's 144 square inches in 1 foot square, right? The square applies to the 12 and the unit. The square to the 1 squared is 1, and the unit. So we got to divide this by 144. And so we get 1.9277 square feet. It says round to the nearest square foot. So that's 2 square feet. Read the directions. 44. Get a suitcase 3 foot long. L is 3. 1 foot wide and 2 foot high. Hold 1 million $1 bills. So 1 million. This is one of these questions where, I think the school should really pony up the resources so we can actually try this out. I'll tell you what, we'll split it 50-50. I'll bring the suitcase and the school provides the 1 million $1 bills. And then we'll just, we'll just go from there. So a single dollar bill is 6.125 by 2.562 by 0.004. That's in inches. So the volume of $1 bill . is 0.06279. So this is a question where you do not want to round until the end. Okay, if you do, this is in inches cubed. If you do, over a million. So let's just say, maybe we'll just do that just to be illustrative here. Let's just say I decide to round that to 0.06. Okay, approximately 0.06. We'll just see how this works out. The volume of my suitcase, 3 by 1 by 2, this is in feet. Okay, so 3 times 1 is 3 times 2 is 6. So that's 6 cubic feet. We just showed up here how to find square feet in square inches. So we got to find cubic. We should probably just convert this to cubic inches because this would be really, really small in cubic feet. So 1 foot equals 12 inches. So 1 foot cubed is a cubic foot. So 1 cubed is 1. 1 foot cubed equals 12 cubed, like 1729, I think. Sorry, 1728. 1728 cubic inches, right? 12 cubed, inches cubed. So we're going to take our 6, multiply it by 1728, and we get the suitcase holds 10,368 cubic inches. So this is my suitcase. Right, so how many of these dollar bills can fit in there if we could max out stuffing dollar bills in the suitcase? So first I'm going to do it by the approximate value, and it's going to tell me I can fit 172,800 of them. And if I do it the exact value, so if I take my 10,368 divided by my exact value, that tells me I only can fit in 165,177. So you can see here, just by rounding, even though I'm rounding to the nearest hundredth, but over the course of thousands of bills, it makes us a $7,000 difference, $7,001 bills difference. And that's a huge difference. Obviously, it's nowhere near a million. And you could figure this out the other way. You could take this number here and multiply it by a million. That's just moving the zeros 6 spots, right? The decimal 1, 2, 3, 4, 5, 6. And so you end up with, it would take a suitcase to hold 62,769 cubic inches. So we would need a suitcase that's approximately 6 times as big. But don't round to the very end if you need to round at all. All right, so the answer here is no. Hopefully you figured that out. Okay. Sorry, my calculator's a lot of focus. Maybe that's a bit better. All right, we're on 46. How much can the paper cup of question 38 hold? So the question from 38, you got a paper cup, base diameter was 10 centimeters and the height of 12 centimeters. And now we're looking at volume. The volume of a cylindrical cup. So pi r squared h. So r is going to be 5 because diameter was 10. So pi 5 squared times 12. And so you get what? 300 pi. So 942.5 0.48 centimeters cubed. This is from 46. All right, 48. An ice cream cone has a diameter of 2, slant height of 3. Find its volume to the nearest tenth of a cubic inch. So volume is 1/3 area of the base times the height. If diameter is 2, radius is 1. So 1/3 pi 1 squared times, oh, we need the height. They gave us a slant height. So in a cone, draw a really bad cone picture here. There's my cone. So if this is 1, the radius is 1, and then this is the height of the cone, and the slant height is 3. So you see we got a right triangle here. So 1 squared plus h squared equals 3 squared. So 1 plus h squared is 9, h squared is 8. So the height is the square root of 8. So over here we had 1/3 pi 1 squared, and then it's going to multiply by the square root of 8. That's the height. So we're rounding to the nearest tenth of a cubic inch. So 1/3 times pi. Oops, not h. Stupid thing. Times pi times 1 times, it's important you put times 1, otherwise you're going to get it wrong. Not really, but you know what I'm saying. So we get 2.9. You got to round it to the nearest tenth of a cubic inch. That 6 rounds that 9 up to 0 in this case. So we're bumping up to 3 cubic inches. Switching to green. I got one of my daughter's drawings. I don't know what this is supposed to be. All right, we're on number 50, getting to the end. The Hagia Sophia in Istanbul was built in 532 AD by Justinian. Hopefully you knew that. The Church of Holy Wisdom. His wife, can't remember her name right now. I want to say it's Sophia, but could be wrong. She's quite the lady. Daughter of a bear trainer, I believe. Yeah, awesome history there. Its great dome is a hemisphere with a diameter of 107 feet. Okay, it's a hemisphere, half a sphere. Find diameter. Find the volume of the dome to the nearest 1,000 cubic feet. So volume is 4/3 pi r cubed for a sphere, but for a hemisphere, it's half of that. So 2/3 pi r cubed. Remember that from the proof we did. So 2/3 pi, the radius is going to be 53.5 cubed. So we get 320,715.51, but we're supposed to round to the nearest 1,000 cubic feet. So this 715, et cetera, is going to bump us up to 321,000 cubic feet. We skipped 52, so we're on to 54. Give two expressions for the area of the rectangle. So I'll have to draw this one. See, what a great drawing. R7, oops, P, Q. So one way is just P plus Q times R plus 7. And then the other way is to multiply it out. So we got PR 7P RQ 7Q. So PR plus 7P plus RQ plus 7Q. Here's your two ways. 56. It says give two expressions for the volume of the box. So same type of deal, except in 3 dimensions. Not drawing this, so you can look at the book. So one is just to write the dimensions like this, and then the second way is to multiply that out. So z times y, yz, z times 5, 5z, 10 times y, 10y, 10 times 5, 50. Now take this mess times x plus w. Yz times x, xyz. Yz times w, y, wyz. 5z times x, 5xz. 5z times w, 5wz. 10y times x, 10xy. 10y times w, 10wy. 50 times x, 50x. 50 times w, 50w. Okay, that's the chapter review. If you have any questions, email me. I think the test's going to end up being Thursday.